the chord of today's imaging. When I was working on my doctorate, one of the projects I was working on was special film techniques, and so I went with Don and brought my 24, in the days of film, remember that stuff, 2415 recording film, and a tank of hydrogen gas and a hypering chamber I built down to Coral Gables. And so Don and I wander in and go into the kitchen where his wife Mo's seated, and she says, "What are you going to do with that hydrogen?" And Don says, "We're going to put it in the oven. That's what we're going to do with it." So it is absolutely my pleasure to introduce Don Parker. Dr. Parker, as you know, is a retired anesthesiologist.
It's working.
But is so well known for his solar system studies. And this afternoon, he's going to talk to us about weather and the solar system. Dr. Don Parker.
Thank you, Mike. Thank you. Can you all hear me back there? I don't know if you use the mic. Shut up, Troy Annie. All right. Well, light travels faster than sound, so that's why some people appear bright until you hear them speak. So we'll see if I can live up to that. Okay, first of all, I'm not going to talk about global warming. I don't think I need to anymore, right? I'm just going to show you what Mars is going to look like tonight at 11 o'clock. This will be 11 p.m. tonight, and just give you some features because Mars will be kind of about 75 degrees up for everybody. And this is the way it would look through a reflector or a Dobsonian or something without a star diagonal. If you can get a Dobsonian not to blow over tonight, it'll be fine. This is south. This is the evening limb, so Mars rotates from right to left. And the most prominent feature is called Syrtis Major, which is a big volcanic plateau. Those lights are dimming. I'm not having a stroke, is that right? Yeah. Okay. Jeez. Yeah, I got a little, let's go to the light. Okay, anyway, that's a very prominent feature, and each night it'll appear about 10 degrees farther toward the AM limb. So the whole week that thing will be very, very prominent. And if you watch it as Mars rotates, it turns blue. That's a mysterious feature called the Syrtis Blue Cloud. Here's an example of it. It took about a month ago, 3 weeks ago, and you can see it just coming up on the morning limb, and it's really intensely blue. So if you happen to have a yellow filter and Syrtis is over near the limb, put it up there, and yellow and blue make green. It becomes an iridescent green. It's kind of a pretty thing. It's one of the few times you can really see color on planetary surfaces. And another feature is this Meridiani sinus, which is the Greenwich of Mars, 0 longitude. And the reason I'm pointing this out, it's like an inverted pipe. And back in 2001, Tippy D'Auria led a expedition down here to the Keys where we replicated a flare, a Martian series of flashes that were seen by a Japanese observer back in 1954. And Tippy mentioned that in his talk, and what he didn't mention was that one of the guys on the team was named, what's happening, Tim Parker, who's no relative. Did my voice change? Okay. And Tim was from Jet Propulsion Lab and worked on the Mars Global Surveyor team. And so we worked out a lot of the math and found out that it wasn't flashes off clouds or anything like that, but it was actual surface terrain. The Mars Global Surveyor looked real close, and they said, yeah, this is a really neat area. And we got credit for being one of the reasons they put the Opportunity lander down in Meridiani Planum. So, and that was in Scientific American. So Tippy, take a bow there. Okay. Okay, and then over here we'll have Chryse, the plain of gold, where the Viking lander is, a thing called Acidalium Mare here, and the North Polar Cap, which may or may not be there tonight, because there's been a big dust storm now in the north. This is Damien Peach back in January 29th. You see that yellow glop on the polar cap? You see how it's progressing? And this is why we like people in different longitudes. This is a guy from the UK, and this is a guy from Puerto Rico. Here we have a fellow from Georgia, seeing different aspects of Mars, and you can really follow that dust storm progressing. Very unusual this time of year on Mars to have a dust storm like that. And I don't know what to make of it, but it seems, again, part of the climate change we're seeing on Mars. This is a 1 meter scope at the Pic du Midi in the French Pyrenees. Ain't bad. But this was taken February 2nd. That just shows that dust. And there's another feature of just, you know, I'm mentioning this for both people who are interested, but there's a, there's a thing called violet clearing, where normally when you look at Mars through a blue or, dark blue, like we're at in 47, dark blue violet filter, you don't see any surface features. You see them very poorly. And you image them very badly. They're because Mars's atmosphere is normally opaque to the short wavelengths. And the last few days we've had a thing called violet clearing, where we're seeing the surface features almost as well as we see them in red. And the professionals, however, deny that this happens because their computer models refuse to show it. I was at a meeting a few years ago, Fourth International Symposium on Mars, and I presented some of my polar cap junk, and one of the astronomers raises his hand. The old guys know about this. The young guys don't. And he said, Don, what about violet clearing? And that just erupted, a big fight in the room. So he and I went to the bar. And I'm serious. He had a big smile on his face. He said, come on, let's go. And they said, oh, it's impossible. Well, it is possible. It does happen, but they still deny it, I guess. So we'll talk a little bit about weather in the solar system. And we're going to talk about the gas giants first. This is Jupiter, which is, of course, the biggest planet. You can see Jupiter compared to Earth here to scale. And lots of stuff is going on Jupiter. I'm going to digress a couple of times in this talk, and this is about impacts. I think Tippy mentioned this too, that he was one of the first ones to see this Shoemaker-Levy 9 impact. And this is a whole series of, I think, the 21 impacts that hit Jupiter back in July of 1994. This was a really big deal. It's the first time anyone had ever seen two solar system objects collide. And this was 1 to 2 kilometer fragments. We all thought it was like a mosquito biting an elephant, until you forget that those fragments are going at 100,000 miles an hour. And a little bit of kinetic energy, and of course these eruption fallout areas are bigger than the Earth. So, and it lasted for months and months. So this was really neat. We thought, well, it's a pretty rare event. It got everybody, making movies like Armageddon and talking about impacts. And lo and behold, this fellow, Anthony Wesley, down in Australia back in July, was just doing his routine observations, and he saw this little dark speck up there, and he was smart enough not just to image it, but to realize what it was. It was another impact of a asteroid or something, probably less than half a mile across, whacking into Jupiter. And he announced it, and the tragedy of this story, it's a tragic story. The night before, Jupiter goes around in 10 hours, okay? The difference between us and Australia is about 10 hours, and I've been imaging Jupiter every night I could also, except the night before was my daughter's birthday. So, and I had to take like 9 people out to dinner, so that depressed me, number one, because, MasterCard, it was shrinking. And so I had 3 pina coladas, which I really like. I got home that night with Maureen, and I said, I'm not going to image tonight. I just feel like crap, and so I went to bed. Next morning I got up in the email, and there's Anthony Wesley, he discovered it. But my darling wife was a big help. She said, it's your own damn fault, so that takes care of that. Anyway, that's the impact. And I got it a few days. Actually, I got it the next day, but I got it, you can see it spread out. And what I'm going to show you now, Hubble did one image of it, but that was it. I mean, Hubble doesn't spend a lot of time in the solar system. What I'm showing you now, they put a composite together, and I'm trying to remember the guy who lives up in Georgia who did this, of all the amateur images of this thing over a period of about 2 months. And there's the impact. Watch, it starts. See it? Isn't that cool? So the same longitude. And you can also see the differential rotation of the various cloud bands on Jupiter and everything. It's really neat. The guy's name is Theo Remekers. He's up in Atlanta. And Hans-Georg Mettig is the astronomer in Germany who really puts all this, these things together. So, okay, so Jupiter rotates very fast, 10 hours. And for something that big, you think we go around 24 hours, and Jupiter's, just causes a tremendous amount of winds and clouds. What is the windiest planet on the solar system? Is it Jupiter? Neptune, that's right. 1,000-mile-an-hour winds there. Jupiter is a mere 400 or 500, But anyway, and it causes various vortexes to form, like this one, which is the Great Red Spot, which has been there for 300 years that we know of, and maybe 30,000 years, we don't know. But since I've been looking at Jupiter, this thing has been there. It's not a hurricane. It's an anti-cyclone. It's a counterclockwise rotation, like hurricanes, but it's in the southern hemisphere. So that makes it a high-pressure area. And it's still one big storm. And then in 2006, Chris Goh in the Philippines discovered that one of these ovals had turned red, and he termed it the little red spot. And showing that amateurs can really contribute, the pros went berserk over this, and Chris is now on the Hubble imaging team. I mean, he's an amateur. I mean, he's really working with these guys. And they determined that this had the same characteristics as the great red spot. It was just smaller. And then along in 2008, this guy Anthony Wesley, my nemesis, discovered the baby red spot, which also was an anticyclone. And, extreme winds and that sort of thing. And unfortunately, the baby red spot was swallowed up by its parents. And you can kind of see it getting swallowed up by the great red spot. So there's only two of them there. But these are very, very unusual weather phenomenon. And the neat thing about this is this guy Phil Marcus at UC Berkeley several years ago in 2004 predicted these changes would start occurring in 2006. That we'd start seeing more vortexes, because he said that Jupiter has been warming by 15 to 20 degrees over the last few decades. Phil probably made 500 other predictions that didn't come true, but you got to go with what you got here. Now we go to Saturn, and Saturn, goes around the sun, 28 years or something like that. 30 years, 29 years. And normally, you look at Saturn, it's really pretty, but you don't see much. So I used to joke, I said, Saturn's great, because I take these images of it, and then every 15 years I turn them upside down and send them back in. Well, thanks to the marvels of CCD imaging, we're now seeing stuff on Saturn. That's a storm up there in the temperate zone. You can see them, these white dots, these are storms moving. And they're very hard to see visually, but now with CCD imaging, you can really see it. And when you send spacecraft there, like the Cassini, we see this thing, which is a bit bigger than the United States. They have lightning bolts hundreds of miles in diameter on Saturn, so it's a very violent planet also. It doesn't appear that much because it's got a methane haze. That's ammonia crystal haze, which obscures a lot of the clouds. But a lot of stuff going on Saturn. There's in the South Polar region, major activities. And now they say the temperature on Saturn in the South Pole at least has increased by 3 to 5 degrees Kelvin, which is significant. Uranus, again, you look at it with a telescope, it's kind of blah. But there has now been some increased activity on Uranus, again, in the form of these storms, which was quite a surprise to the professionals. An alert went out in 2005 for amateurs to try to image this stuff, which no one has yet. It's a tough object. Neptune is changing phase. Again, Neptune, it seems to be having more activity. Neptune is a bit more reliable because you don't have the seasons that you do on Uranus. The axial tilt has been pretty constant over the last many years. So this just kind of gives you an idea. Oh, this is Neptune. It's brightened also over the last half century or so. And one of our guys in ALPO has been doing whole disk photometry of Uranus and Neptune and Pluto, and found that for some reason Neptune has brightened. Also, this kind of correlates with the change in temperature on the Earth, the solar irradiance, and the solar UV flux. Also, it correlates with the price of women's shoes in Czechoslovakia. So what I'm saying is Pluto is warmed from occultation data, Triton is warmed. But except for Jupiter, we don't have a whole lot of historical data to back all these temperature changes up. I mean, it's interesting and something to keep our eye on, but the spacecraft have been there for anywhere from a few months to maybe a decade or two. And very often these observations are based on 2 observations, which gives you degrees of freedom of 1, which any statistician would kind of look suspiciously at. So again, you take this with a grain of salt. And most of these announcements come when it's funding time for NASA. So I'm serious. This is not a joke. Okay, but anyway, Jupiter does seem to be having increased activity in Saturn also, so there may be some warming in the outer solar system. But now we'll get to something really interesting, which is my planet, Mars. And I would like to point out, I'm very proud of the fact I've been observing Mars for 56 years, and both I and my telescope have doubled in size over 56 years. Okay? All right, Mars, very Earth-like. Other than Mercury, who's really seen Mercury through a telescope? Well, you guys probably have, but, sort of. It's the only planet whose surface we can see. And it does have clouds. These are water ice crystal clouds. Remember, clouds, vapor doesn't make clouds. Right, Mike? It's water droplets, which don't exist on Mars because of the pressure. It's water droplets or water ice crystals. So that's just one thing. We'll get to that a little bit later. But anyway, you can see these are some of the clouds over the big volcanoes on Mars toward the afternoon. This I took back in January. See these big clouds along the evening limb, like, it's like you get in the Rocky Mountains in the summer where you get those big orographic clouds. These are the same thing. That's Olympus Mons. And, okay, and there's that dust storm, which I didn't notice on January 23rd, or I could have been the discoverer again, but, you get old, and, geez, whatever. Okay, and there's a fellow named Emil Krijnkamp, I think. Are any of our friends from Holland here that can pronounce this correctly? But yes, is that correct pronunciation?
Almost.
Okay. What is it, Rob? What is his name?
Emil Krijnkamp.
Oh, okay, Krijnkamp.
What you said?
Yeah, I said, not really. I was close. I got the K right, but other than that, it was, Okay, but here, he just does beautiful work with just nice amateur instruments, and he's showing these clouds as they develop in the afternoons of Mars and brighten toward the evening. These big clouds over the volcanoes. It's really cool. Okay, anyway, Mars also has polar caps, and that's usually the first thing you notice on Mars. This is back in 2005, and the south is up on all these. South polar cap was kind of shrinking, regressing, and has a lot of little cracks in it. And here's another one of these Dutchmen. I don't know what to do with these guys. Richard Bosman. Correct, Bosman, right? Yes, thank you. This is back in 2005. This is the first day of spring on Mars, and as spring progresses, the cap gets smaller and smaller until you get to midsummer. You can barely see it at all. So just like the Earth, Mars's polar caps wax and wane with the seasons. And it had been written in stone for many, many years that it was always the same. That every Mars year, which is 2 of Earth years about, the caps always retreat in exactly the same fashion, exactly the same size, and that sort of thing. Now, whenever you see the word always or never in science, never believe it. Because my friends in Holland won't understand this, but the only absolute in nature is there will never be a Richard Simmons Jr. All right. So, do they retreat the same way each year? And I'm a member of the Association of Lunar and Planetary Observers, which is a worldwide organization, it's ALPO for short, worldwide organization of amateurs and professional astronomers who cooperate. And we have professional mentors. And many years ago, this was my mentor, Charles F. Capon, Chick Capon, who was at Lowell Observatory. And he said, he was one of the world's experts on Mars. And he said, I'm not really sure that cap retreats the same way each year. He knew damn well it didn't, but nobody else did, and there was a lot of controversy. So, and Chick also was hard up for money. So he said, we're going to explore the Martian Arctic, and I'm going to sell you this bifilar micrometer, which is a very nice device. These has spider webs here, and you use a micrometer screw to measure the webs, move one of the webs back and forth, and you can measure surface features. And until very recently, this was the most accurate way to measure planetary surface features. The one I originally used at Lowell Observatory used a black widow spider web. And those of you from Arizona, the black widow is the state animal in Arizona. They had them all over the place, and they actually would have like a fork, and they go to a black widow web and turn it, and the widow would, be spinning like mad, and they get the threads and put them in the micrometer. Thank God for monofilament, because 6 legs, in Florida, things with 6 legs you're used to, but not 8. Eight's not good. So anyway, Jeff Bish and I did lots of measurements starting back in the 1970s of the Mars's polar caps. You go back and forth. It's kind of like using an analytical balance. Any of you remember quantitative analysis? Up and down like that. We do a series of 8 of these measurements at least per evening. And this was very exacting work, as you could imagine. Extremely delicate. And over the years, we did about 10,000 of these micrometer measurements. And now, thank goodness, we did a statistical analysis, and we can use red light CCD images instead, which is a lot easier, instead of standing on a ladder doing these things. But that's over about a 40-year period, and we found that Mars always has surprises. And it says, "That's not chicken." Okay? Sort of like eating in a Chinese restaurant. And this, I think, is a self-explanatory slide. This, we can move on now. This is just an example of what we found. This is the North Polar Cap. In this case, the horizontal axis is the season. We go from northern spring to northern summer. The vertical axis is the latitude of the edge of the cap. So at 60 degrees would be somewhere between the Canadian border and Hudson Bay up there in Canada. 90 degrees would be the North Pole. And, no big surprise, the cap retreats with as summer approaches. The thing we found very interesting is that the cap was much larger in the 1960s than it was in the 80s and again in the 90s. So we found this kind of neat. And remember, in those days, global warming was not a term.
They just didn't ship the SUVs up there yet, right?
No, that's right. I'll get to that in a minute, though. That's very good. That's right. So anyway, global warming wasn't, this was not something we thought of. And but we just presented the data, and I presented it at some meetings and gave the statistics, and I got to dig up those raw statistics again for Mike here. And it was gradually accepted that that the cap is different every year. This is some of the I got to co-author and first author some papers in Icarus, and these guys, Kiyosuke Iwasaki, who taught me how to drink sake, Steve Larson and Akabane, these were the deniers. You've heard that term now about global warming. We're deniers. They were the polar cap deniers. They said it's always the same, and as good scientists do, which apparently doesn't happen much anymore, these guys reversed. And they said, yeah, we got good data, and they've been now doing the studies and showing that indeed it was the same. So that was kind of a neat little coup. And we said, well, Mars may be undergoing some global warming. And again, the Mars Global Surveyor, which looked at Tippy's findings there on the Meridiani sinus, they investigated, and the same year, same Mars date for 4 Mars years, they took a picture of the South Polar Cap, the exact same area, and they found that it retreated from the late 90s into the early 2000s. The cap had lost hundreds of square kilometers of ice over that 4-year period, each Martian year. So they came out and said, yeah, that's very interesting. The Viking lander showed that Mars was cooler than it was with a Pathfinder back in the early 2000s. And Laurie Fenton, who's a astronomer at Jet Propulsion Lab, published this in Nature. Mars' surface temperatures increased by 0.65 degrees centigrade from 1975 to 2000. And that 0.65, that's what the Earth is alleged to have increased. But Laurie, being a professional NASA type, said, well, that's because dust storms have increased on Mars. Now, Dan Troiani, head of our Mars section at Alpo, what causes dust storms on Mars, Dan? Right, it's that thing sitting up there in the sky. It's well known that that generates the energy for dust storms to occur on Mars. This is an example of just some dust devils. That was taken from the Opportunity lander. It's kind of neat, that's all. The reason I showed it. But they're all over the place, and the number of Mars dust storms, the big ones, the global ones, there have been 10 of them since 1877, and 8 of the 10 have occurred since 1956. So they do seem to be increasing in frequency, but again, it's not the dust that is causing this warming, it's probably the sun. And Michael Malin, the head of the Mars Global Surveyor, 2 years ago at a meeting said Mars is experiencing global warming and we don't know why. Now, to go back to your thing about the SUV, the Martians do know why. They point out the temperature on Mars has increased since the 1970s. And the cause of this, the same thing is happening on Earth. And then, Earth just landed another space probe on Mars. Come to think of it, the Earth has been sending space probes here since the 1970s, so global warming is man-made. Okay? So now we'll talk a little bit about global warming on the Earth, and Mars, maybe Jupiter and some of the other planets are warming, but is the Earth warming? This is proof that the Earth is warming. So thank you very much. That's okay. It's probably gone up 0.6 degrees in the last century. And this just shows here from 1860 going up, dramatic temperature increase. But the good news is that this is the worldwide temperature increase, and this is the United States. We're much better. Our temperature doesn't go up as much, right? Okay, these two graphs are identical. Same data. But if you look closely, this is, the scale. This is 1 degree and that's 3 degrees. So what you have to do when you leave here, you go on Google, you spend about $6 and get this book, How to Lie with Statistics. It's a terrific book because it was published in the 50s. I had an algebra teacher who made us get it. And it's kind of archaic because they talk about, streetcars and things that don't exist anymore. But basically, it gives you really good ideas. It's not complicated at all, but it allows you to look at advertisements, political ads, all this kind of stuff where they're showing graphs and charts and realize the amount of BS that has gone into it. So the climate is always changing both here on Earth and in the solar system. I think that's one thing that I get out of all this, that things are changing constantly. And we're talking about Earth's temperature. This goes back 3,000 years. And back here in the late Holocene, you can see it was very much warmer than it is today. Now this is the year 0, or there wasn't a year 0, but this is BC. So from 1,000 years BC, what happened during that 1,000 years BC? Was it good stuff or bad stuff? It was hot. We're all going to die. The species are being eradicated. No. We had agriculture taking off. We had the Babylonians, the Egyptians, the Greeks, the Romans, the great civilizations. They're kind of mean guys, but this is when civilization flourished. And then after a while, it got cold. And it's a period we call the Dark Ages, where bad things were happening. This is not totally due to weather, but a lot of it was because, remember, we're an agricultural society, even today. I mean, aside from Mickey D, of course, McDonald's was, but that's another thing. And then we went to a period about from 900 to 1350 AD called the medieval climate optimum. And people are trying to get rid of that. They don't like that because it was quite a bit warmer than it is today. Here's 2006. This is the average temperature over the last 3,000 years. And after the medieval climate optimum, where the Vikings went to Greenland because it was green, and the English were growing wine. They made wine that was rivaling the French, and the French were really upset about this. I mean, there's all kinds of, snotty remarks in the literature about this. Then they went into a thing called Little Ice Age, part of which was this Maunder Minimum, I'm sure you've all heard about, 1600 to 1715. And there was a period of really prolonged cold, interspersed with some warm areas, warm times. The climate changes all the time. But basically, in the last 1,1500 years, we've had a medieval climate optimum, the Little Ice Age, and now we're back warming up again from the Little Ice Age. Now there's a group called the IPCC, the Intergovernmental Panel on Climate Change, who these are the ones who are driving the idea that man is causing global warming on Earth. And what they have done, they've taken studies from like 1,500 different scientists, published studies, and they have taken data from them and made policy statements. So a lot of times, and this has happened more and more recently, what these 1,500 scientists said, they read the policy statement, they say, I didn't say that. And what the heck is this? And a number of them have sued to be taken off of this IPCC list. The IPCC itself is mostly policy wonks, not scientists. They have what they call scientists or plastic surgeons, urologists. I'm sorry, Manny. Manny's here. They have architects and people like that, but they're not exactly climate scientists. So mostly they make policies designed to screw the United States. Okay, I'll just point that out. I don't want to be bitter. I'm not bitter, no. Okay, here we go back. Medieval warm period, Little Ice Age. And there are 650 different authors over the last 25 years, thousands of pages, who have really, shown this stuff really happened. And there's historical records. This was worldwide climate events. But now you see it. In 1990, the IPCC published this, and then all of a sudden in 2001, you don't see it anymore. This is the hockey stick curve by a guy named Michael Mann at Penn State University, who analyzed tree rings in Siberia, and he said, no, the medieval climate optimum didn't happen. We used 3 trees. We went overboard and cut down 3 trees. And the IPCC in 1990 said tree rings were not reliable for this because temperature is not the only thing that affects tree ring growth. But anyway, he became very famous for this hockey stick curve. And it was very difficult to get his data. It took 3 years for a couple of any Canadians here? Okay. Well, listen, I have to admit that some of the best work on this stuff has been done by Canadians and Danes. And, and of course Dutch, you know. Yes, you're welcome. Two Canadians named McKittrick and McIntosh came along, and they said, you know, this data is not right. They finally got his man's data. And they said, this guy's attempting to disguise the medieval warm period. You know, we've heard about ClimateGate back around Thanksgiving last year where they discovered these hacked emails, and this is all part of the deal. And they said, well, here's this famous hockey stick, and they found that the program he was using with his data, you could put, again, the price of women's shoes in the Czech Republic into it, and you would get a hockey stick. In fact, almost anything will give you a hockey stick. I think the reason the Canadian statisticians got onto this is because hockey. Yeah, okay. I just thought of that, you know. Hey, good match, eh? Okay. So they have pretty well gotten rid of this, and the IPCC has now deleted this from its 2007 report, although they didn't advertise the fact. And Jones at East Anglia University, I've heard of him, and Michael Mann kind of come out looking like Inspector Clouseau and Dreyfus. But they still say, even recently, we must get rid of the medieval climate optimum. That was in their emails. Okay, why is the Earth warming? Carbon dioxide is blamed. And this is the IPCC report. The recent one, most of the observed increase in globally average temperatures is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. That means we're causing it.
And then I make a big word, didn't
A big word, yeah. Well, I call it AGW, anthropogenic greenhouse, you know, well, whatever. Okay, how does this greenhouse effect work? The greenhouse gases don't act like a window pane. They're not bouncing light back. But what happens is the sun's radiation hits the Earth, it turns into infrared radiation or heat, and it's radiated either back into space or gets absorbed by the molecules in the atmosphere and re-radiated back to the Earth. And the three molecules, very prominent, are methane, which I'm very familiar with, methane, carbon dioxide, and water, vapor. Well, just ask my wife there. Okay, anyway. And, you know, these absorb the infrared radiation coming up, and they re-radiate it back down to the Earth. And when we emit more carbon dioxide, we are increasing the greenhouse gas concentration of CO2, and therefore makes the Earth warmer. So there's a factory doing just that. So this is bad. So it absorbs infrared radiation from the ground, but of course carbon dioxide is not the main component of greenhouse gases. Water vapor is. Again, not water ice crystals or water droplets, water vapor. And that accounts for very 95% of the greenhouse effect on the Earth. So it gives you an example. If you take all the greenhouse gases, water vapor is by far the most, and you have carbon dioxide and methane and all the others, the human contribution to greenhouse gases is about 0.3%. And if you just use CO2 in that, it's 0.1, it's 1/10 of 1%. Now let's put that in a different term. Being a football fan, I'm here in the Rose Bowl, and my team I really hate, which is USC. Anybody here from Southern California? I don't want to upset them, but USC is about to get scored on. Yay! And the Rose Bowl, if any of you have been there, it's a great stadium. It's really 100,000 people. So let's say each person represents a molecule of gas in the air. Oxygen, nitrogen, arid, extra dry, whatever, you know, it's up there. Okay, and how many of these people here would be the amount of man-made carbon dioxide that we put in the atmosphere? Yeah, it's that guy there in the red hat, okay? So I just want to point this out that, you know, we're talking about very, very, very tiny contributions that we're making. And the other thing which is very important is that all of greenhouse gas things you see, you know, movies and whatever about how this works, they think that these molecules are really smart and they only radiate it back down toward the Earth. Whereas they also radiate the infrared they've absorbed into space, and they go to other air molecules. So they should be heating up the air in the middle troposphere, it's called. And all the computer models of greenhouse gas warming require that the middle tropical troposphere gets warm. It's called a hot spot right here, which is right where we are now, in fact, except up about 10 kilometers. And see, I learned that in Holland, Rob. Kilometers, not kilometers. I hate that kilometers. You know, you say, oh, this is, I have a 25 millimeter eyepiece. Okay, anyway. All right. So this is called a hotspot. Well, guess what? The hotspot ain't there. And for 50 years, they've been looking for it. They've been sending up balloons and satellites, and it's not there. And this kind of negates all the computer models, because they do require that if carbon dioxide is causing this warming, this increase in carbon dioxide should cause this hotspot to appear, and it doesn't. So there are 5 problems for, this is the last time I'll say it, anthropogenic global warming, AGW. One is there's no hotspot. The other is a nasty little feature about the carbon dioxide. This is their other cornerstone, that the temperature and carbon dioxide vary together. Temperature goes up, CO2 goes up. I don't know which is which here, but they go up pretty well. And that's really cornerstone of the AGW theory. Well, correlation does not mean causation, as I gave with my women's shoes example. Or if correlation and causation were linked like that, we could say lung cancer causes smoking. Or every time I see a dog salivate, I have an urge to ring a bell. Okay? And the dirty little secret is that the carbon dioxide goes up after the temperature increases. And where is this carbon dioxide coming from? It's from the oceans. Oceans hold an enormous amount of carbon dioxide. And it's just like opening a can of beer. You know, the beer gets warm, and you stand back when you open it. It's the same thing. Some people think that's counterintuitive, but warm water holds much less gas than cold water. And you go diving out here on the reefs and all this beautiful fish, nice warm 80-degree water. You think, wow, this is really good. Well, if you take a square mile of that ocean and look at the amount of life in it, and then you go up off Cape Cod or the North Sea and take a square cubic mile, you're going to find there's a whole lot more life up there where it's cold, because there's more oxygen dissolved in the water. That's why all the big fisheries are up north and in cold waters. The whales know. That's where they hang out. This is my lovely wife. We're going after the dreaded great spiny lobster here. Okay, anyway, they say that the rising carbon dioxide in the atmosphere, basically human activity is minor, and the most fact comes that we're still recovering from the last ice age. Not just the big ice age 12,000 years ago, but the little ice age. And the oceans have been warming and expelling carbon dioxide. Okay, it changes after the temperature, and the next thing is that CO2 is absorbing almost all the infrared it can. This is not a linear function. You know, the first 20 parts per million absorb 95% of the infrared coming from the Earth. The next 20 parts per million, 95% of what's left, so on and so forth. So if we go down here, the pre-industrial level at 280 and go double that, or not double it, but we run up to 380 where we are now, there's very little increase in the warming effect of carbon dioxide. In fact, if you double the CO2 in the air, which we'd really have to work pretty hard to do in the next few years, I think you'd change the temperature of the Earth by, it would be less than a degree. It'd be about 0.2 degrees or something centigrade. So again, we're making a big deal out of something we really can't control anyway. Okay, and the big thing too is the computer models fail real-world tests. Now, there's only one computer model I trust, and that's Patty Dioria here modeling a computer for me. If you put in the data we have and run them backwards, they don't work. It's just, you get the same result as if you use random numbers. So you think that you've got a climate model, it should work both ways. You should, because you know what happened in the past. That doesn't happen. They fail to explain why the hotspot's not there, and they totally omit the big factors in climate change, which is the current ocean currents, the Pacific Decadal Oscillation. This change about every 30 years, and this has caused a lot of the change in temperature off the waters of Alaska. The El Nino, which is what we got now. By the way, El Nino predicts that we're going to get a lot more cold fronts in Florida, which we've had, as you know. We call these cold fronts, okay, you know. But you know, lots of winds, rain, cool weather. It also predicts, however, that you get very mild winters up north. So, yeah, so much for the computer predictions again. These models, and this is really important, they don't include clouds or precipitation. They say, oh, carbon dioxide warms the water vapor, or warms the surface. More water is evaporated. Water vapor is a greenhouse gas, and it causes Earth to warm. but they don't include the latent heat of evaporation. They don't include the precipitation, the clouds that are formed. For some reason, these sort of come from some mysterious place. And the other thing they don't really touch on in these models is this thing up in the sky that's putting out 5 times 10 to the 26 kilowatts. Most of the IPCC in these reports, they say, oh, the sun, they acknowledge it's a variable star, but it's just not enough to really bother with. But there is a much better correlation. This is carbon dioxide in the red line, and that's Earth temperature in the other lines here. There's a better correlation with the solar activity than there is with carbon dioxide. It's kind of neat. Solar activity, the theory now, there's a guy in Copenhagen named Svensmark who is, he's a nuclear physicist, or a nuclear physicist. And he has done this, first of all started with the theory, and then he did a lot of experiments. And then he got a co-authorship with a guy from Berkeley, I think it was Berkeley. And when the government discovered, or Berkeley discovered what they were working on, they canceled the grant. So Svensmark is now working in his basement in Copenhagen, and which shows, I'm serious. But anyway, it shows, his theory is increased solar activity, you get increased magnetic field, increased solar wind essentially, and that causes a decrease in cosmic rays, high energy cosmic rays striking the Earth. And so you get more activity, less cosmic rays, and what do cosmic rays do? They cause clouds. So if you have more cosmic rays or less cosmic rays striking the Earth, you get a decrease in the low-level clouds, not the high cirrus clouds, because those warm the Earth. But I'm talking about your average, everyday, low-level clouds. And the reason being is that the muon, which is a particle that's split off when a cosmic ray hits the upper atmosphere, is the culprit. It goes down and forms a nidus for these water droplets to form clouds. And we can get into that a little later, but the muon's half-life, it's about a millionth of a second. So they say, well, it couldn't possibly go more than a few hundred yards. And that was a big argument for the deniers. They say, well, muons don't work. And then this guy Einstein pointed out that, well, from the muon's point of view, it wasn't a millionth of a second. Muon had more than enough time because of Einstein relativistic time dilation, so whatever. And I really hate that stuff, so we'll move on here. So one more little detail here, which is, again, they're trying to hide. This is this area between 1940 and 1975 or 80. And the Earth's temperature actually decreased, and yet the CO2 rose. It also decreased in the 40s, 1940s. Well, this is the 40s, but there's some war going on there where we're really putting out a lot of carbon dioxide in the atmosphere and all kinds of greenhouse gases, and yet the Earth's temperature went down. Now, this has been denied in the last issue of, I think it was Science or Nature, one of those magazines, that no, it wasn't really that cold and all that sort of thing. But some of these same guys were writing these articles back in the 1970s, National Geographic. The same guys who were screaming about warming now are writing these articles that, we're all going to die from an ice age. And I'm old enough to remember these vividly. Oh no, we're all going to die. They want to put carbon black on the polar caps to melt them. So again, CO2 was going up then, but the temperature was going down. They don't really explain that. And the final thing, the Earth isn't warming anymore anyway. The last 8 or 9 years now, temperature's actually gone down almost 0.6 of a degree, which is what it warmed up during the previous century. Again, this doesn't set well with the warmists, I call them. And this is where we, again, saw in the emails about ClimateGate, the manipulation of, this is called the nature trick, and hide the decline. Hide the decline is their latest, rallying call. And so they read the book, How to Lie with Statistics, and the Goddard Institute for Space Studies, which we got friends there. Fred Espinak's up there. It's part of NASA. And they read this book, and they said, well, here's this. In the IPCC, one of their things is Santa Rosa, California, and the temperatures from 1900 till pretty much the present have gone down in Santa Rosa. Well, we can't have that. We have to hide the decline. So anyway, they just made falling temperatures into rising temperatures. And this is what was published, this graph in the IPCC 2007 report. The way they did it, they had a fancy word for it. It's homogenization of the data. And what they mean is that they make these temperatures colder and these temperatures warmer. to fix the slope. When I was in school, I used to call that dry labbing. You know, if you were in the lab and you wanted a result, you just... And finally, I just want to show you this because this is part of that book, How to Lie with Statistics. The IPCC has showed, this was their latest graph, and they showed these squares are ice core data of carbon dioxide. And then since 1950, we've been measuring atmospheric carbon dioxide directly from Mauna Loa in Hawaii. You know, it's out in the ocean, there's not a lot of industry or anything, and it's pretty accurate measurements. And they say, well, look how well this carbon dioxide has just been going up and up and up, especially since the Industrial Revolution. This is one of their proofs. Well, I forgot their names, but it was a couple of Canadian scientists again, got this data by SIPL. They looked at it and they said, yikes, this was what SIPL found, that this is about 1960 or so, or what is that? Oh, 1900. And gee, it was, the CO2 concentration was almost as high as it is today, back in 1900. And something's wrong here. Well, what the IPCC did, they looked at this and they said, oh, we just take this graph and we just shove that over 83 years, and you're all set. That's really what happened. And that's part of that ClimateGate thing again. What they did is they said, according to them and NASA, because NASA was involved, CO2 was trapped 83 years after the ice formed, which is a good trick. So it's a new physics we're doing. It's like the new math, you know? Okay. And they also, there have been 90,000 direct chemical measurements of CO2 in the atmosphere since 1812. And back in the early 1800s, it was even higher than it is today. But these were, you know, old guys like Van Slyke and JBS Haldane who didn't know what they were doing. All they did was invent the technique. So anyway, I'm not bitter, but we're getting into ClimateGate 2 now because Goddard and NASA and NOAA are now involved, and only warm stations are being counted. In the United States, the temperature monitoring stations have been reduced from 6,000 to 1,000. California, I think, has 4 now, 1 in the San Francisco airport, and 3 on the beaches down in LA and San Diego, where it's warm. There's no Sierras in there. Russia found out about this about 2 months ago, that they've been sending this these temperature data to IPCC for many, many years, and only 25% of it was used. And the Russians said, you know, we have a place called Siberia, you're not using this. And they're you know, just raising hell with the United Nations about this. Studies in China denied the urban heat island effect, and it's well known that, you know, the closer you get to a big city or urban sprawl, you got more concrete, more the temperature is increased. But they've been trying to deny this for years. And now they found that a study done in 1991 in China showed that, it wasn't by the Chinese, it was by an American, showed that the urban heat island effect didn't exist. And that's because they kept moving the stations. As the urban sprawl increased, they just move out into suburbs again. So, and the Dutch, by the way, are now upset because the IPCC said 56 or some percent of Holland is below sea level, and it's only about 20%. And so they're raising heck with the people. So these things are gradually, the walls are beginning to kind of crack a little bit. And basically they're cherry picking their data is what the problem is. Okay. Final thing here, the temperature stations are inaccurate. This is a NOAA temperature station in Orland, California. Really nice. Nice field out here. There's nothing around civilization to disturb it. The guy started this as a science project for his daughter, sending her, you know, a GPS. You get all these coordinates and send her around California and Oregon to look at these stations. And they found that it is now kind of ugly because they have built these, you know, asphalt parking lots, concrete patios. California, right, you barbecue. So the people who work here come out for lunch, they barbecue, and you got air conditioners nearby. So Marysville, California, the temperature's been going up. That's a big surprise. And one of the scientists wrote that the major cause of global warming is air conditioning. And it's not air conditioning, putting stuff in the atmosphere, it's air conditioning units next to the temperature stations. This is a map of the United States. Now it's turned into a full-fledged study. About 80 to 85% of the temperature stations in the United States, the surface stations, are 1 to 3 degrees too high in their readings. They're inaccurate. Again, because of, you know, they don't move them or don't change them when things get built around them. And to make matters worse, they've replaced whitewash with latex paint, which increases the temperature at 0.5 degree centigrade. And NOAA didn't correct for this. In fact, they corrected in the wrong direction. Yeah, I mean, this is, the more I read about this stuff, the more I want to go back to electric trains. So, anyway, the next time you hear, this is Jim Hansen at NASA saying, he said this on CNN 2 weeks ago, I happened to watch it. 2009 was the second hottest year on record, and 2006 was the hottest. It was really 1934, but we won't get into that. And so when you see some guy saying something like that, you just tell him to cut it out, you know?
I didn't see Kermit the Frog with Jim there.
Oh, no, that's right. Yeah, no, different Hansen. Different Hansen. No, okay. This is James Hansen. He's a PhD, so he gets James. Okay, one other thing I got, a consensus is in science, and I like Einstein's thing down here. Many experiments may prove me right, but it only takes one to prove me wrong. And I've been asked to talk a little bit about ice, since that's what we're getting tonight. It's going to be cold out there. 2008, 2009, the Arctic sea ice has come back pretty much to the levels in 1979. So we're not going to lose the Arctic. What happens if all the ice in the Arctic melts?
We get rid of Congress and Washington.
Well, hopefully no. No, nothing happens, because if you put ice in a glass and the ice melts, nothing happens. The Arctic is floating, okay? Right? So, I mean, actually, it will go down a little bit because the ice is less dense than the water. If the ice melts, it goes. Now, Greenland, of course, they're talking about, that's a different thing with the glaciers falling into the ocean, which they've been doing for a long time, and that's a whole different story. But, basically, they're all worried about the Arctic ice melting. Well, nothing's going to happen anyway. It may change some ocean currents and stuff, but we're not even near that anyway. So the ice is back where it should be. Antarctica, which, Mike, you've been down there, and the 5% of it's melting and 95% is growing. There's about 1 billion tons of ice deposited every year. This is the Larsen Ice Shelf, which is the what's the name of the other that area? I forgot what the heck it is. Northern Ice Continental Shelf, something of Antarctica. This is melting a bit because it's also drifting north. It's the tectonic plate is moving it. There are volcanoes under here, and the IPCC said that this should, at the current rate, will be gone by 2035. And then there was never mind. Remember Saturday Night Live? Never mind. It's about 7,000 years it'll take for that to go, if it does go. So, again, numbers are just being thrown around here like mad. And I do have to, in closing, talk about our friends, the polar bears, which is one of the few animals that actively hunts man. I thought I'd point that out. This picture was taken by Amanda Bird, who is a graduate student in biology on a field trip in 2004, I think, whatever. I can't remember the date. And she was on this ship off the coast of Alaska. There's a bunch of scientists on there, and she had her camera, and there's some really cute little polar bears on the ice, and you click, click, click. Took some pictures, and she gave them to some of the people on the ship, and never thought more about it. And about a year later, she sees her picture all over the world, including in Al Gore's film, which she thought, Amanda's not political and not really cares about global warming. She's into some kind of snail or something. And she's really mad now. If you Google her, you'll see some of her comments. Because what happened, one of the guys on the ship took that picture, sold it to Environment Canada. Sorry about that, Canadians. And they spread it all over the world. The fact that the ice is melting, the polar bears are all going to die. This was just offshore. A polar bear can swim 60 miles anyway without stopping. I mean, they're incredible animals. And they weren't in any danger. This was August. So Amanda is demanding payment for this picture, and I hope she gets it. Al Gore did pay her for it. I'll have to give him that he did pay for the picture. But that became the poster child for the plight of the polar bear. And the other reason that polar bears they're upset, 4 polar bears died in a storm, I think it was 2001. And with 100-foot waves, a lot of things died in that storm. I mean, they just has nothing to do with temperature. They're doing fine. In fact, they enjoy swimming, and just as they did in warm climates, thin ice, they've been around for a few million years, and where the ice has been thinner, the ice has been not there, and the ice is there now, and they're doing okay. This guy, you see the smoke rings he's blowing? It's my kind of guy. I like that. Okay, so enjoy the warm climate while it lasts and make enough CO2 to feed a tree. And I have to go because I'm going to a rally now, to a global warming protest. Thank you very much. Any questions? Okay, yes.
brought up about the Arctic ice increasing. I saw an article several weeks ago, I think actually George Will wrote it, quoting one of the climate groups out of Colorado.
Yeah.
That said that the sea ice since 2007 has increased by 25% in the Arctic.
Yeah. I saw that, that's right, yeah, it's just coming right back. And I gave this talk, not this talk, but I talked to Fort Lauderdale Yacht Club about 6 weeks ago, and they sponsored this Around the Americas sailboat. It's really neat, you know, this big monster steel boat. They've gone up through the Northwest Passage. And people don't realize the Northwest Passage was navigated by Amundsen in 1903, and it was navigated in the 1940s, you know, and so, but they were through there, and one of the guys was back from that. They anchored the boat in Fort Lauderdale. And he said, yeah, he said they got ice a lot faster than they thought. And they barely got out of there in time, or they would have been, you know, that would have been the end of the Around the Americas trip. So, any other, yes, sir. Hello? Yes.
Why are these,
If you're going to ask a question, you have to stay awake. I'm sorry. Okay.
why are they all falsifying the data? What's their role in that?
Right here, money, huge amounts of money. It's enormous. Carbon exchange, climate exchange, all this stuff. I mean, we're not talking scientists anymore. We're not talking politicians anymore. We're talking big industry and business. There's a $200 billion a year. It's probably more now. That was as of last year, because you know it's a way to make money. It's a Ponzi scheme basically, and you get grants. It's really a shame because, you know, I'm a scientist of sorts, and Mike certainly is, and a lot of us are. I think we all consider ourselves scientists. They're making scientists look stupid, again, really. But that's the only thing. Yes, sir?
I'm not concerned about global warming or cooling, but pollution production. Specifically
Yeah.
China's pollution production.
Yeah.
Would there be a way to rigorously analyze that and present a curve based upon, you know,
We could nuke them, but I guess that's a little excessive. No, that's a good point. They say that something like a third of the smog in Los Angeles is now from China, and which is scary. Have you been to the Texas Star Party? Yes? Okay. And last time I was down there, they had all this stuff coming up from Mexico City, which is, 1,000 miles away? Again, it was pollution. But that's a whole different thing. CO2 is not a pollutant. They're trying to make it sound like something bad. When I was, in the early days when I was practicing medicine back, in the Civil War, we used to have I remember Barbara Boxer came out and said, all the children are going to die of asthma because of the CO2 emissions. Now, they might die of asthma for other reasons, but we used to have a tank of carbon dioxide in the emergency room to give asthmatics when they came in and they were having trouble breathing. CO2 is an excellent bronchodilator. You know, that was back, as I say, in the Stone Age, but we do things better now, but it's still very effective. So carbon dioxide is not a bad thing in moderation. Yes, sir?
Last time I was in Shenzhen, which was in the late 90s, there wasn't a cloud in the sky and you couldn't see the sun. That's just China air.
Just the pollution, yeah.
That's just China air.
Yeah. And, yes.
What about all these pictures we continue to see of Greenland and the ice is just
Well,
melting, and they show the year before it was, or 10 years
Yeah.
before, and now it's very scary.
It's very scary, but some of that styrofoam, it is. You think I'm joking? I don't know. And yeah, the Greenland is melting. I mean, I think that's a good thing because we're coming out of an ice age. Now, if you want to go back into an ice age, we can get Greenland back, and also a mile of ice over New York City, which could be a good thing, you know. But this stuff is, you know, it's constant. And then, the latest thing are those holes in the glaciers where you go down the water. I forgot what they call them, Mike. And water's supposed to melt down there and lubricate the glacier so it's going to move faster, right? And there was many holes in the 1940s as there are now, and the glaciers aren't really moving, you know, it doesn't really appear to help them go into the ocean. Other thing, Greenland is a bowl. So you got all this ice there. I mean, it's not going to pick itself up and come over the rim and slop off. I mean, you know, the whole thing is, the Himalayas, you know, that's the other scam they found really just a week or two ago. And the Indians are upset. Now, they joined the Dutch and the Russians and the Chinese. They're upset because a study, and this is true, I can't believe it, I looked it up. I looked it up, and Mad Magazine. And the Himalayas, the glaciers are going to be gone by 2035. Okay, and that was in the IPCC. Okay, now, an Indian scientist, they're kind of into the Himalayas. I'll get you next. It's about down there. You're about my age, so, I know what you mean. 2035, it's going to be gone, and then comes along another thing, oh, never mind, it was the wrong data. It was like 300 or 400 years. And the drinking water for India and China will be gone. The drinking water comes from snowmelt, not from the glacier. And the source for this was in Climbers magazine. Very good scientific journal. Refereed. Dennis.
Let's go to Mars.
Good.
That ultraviolet clearing.
Yes.
I was curious as to what the transparency of methane is to ultraviolet light.
That's a very good point. Yeah, I don't know. There's methane on Mars now. That's right. Yeah.
We don't know.
Yeah. Now, that wasn't ultraviolet. That was violet. I mean, yeah. The old guys call it violet clearing, and then some of the guys in Alpo said, well, no, those filters aren't really violet, they're blue. So we call it blue clearing for a while. Now we go back to violet, but it's really very dark blue, and of course into the ultraviolet. But methane would be a really cool idea. Yeah. Didn't think about that.
Let's find out.
Yes, okay, we'll do that. Next. Dr. Reynolds, it's your assignment for next year. We'll come and report. Okay, I think we're probably way over time here, so that's it, guys. Thank you very much. Thank you.